Alrighty. Hello, everyone, and welcome to this live webinar. Thank you so much for joining us today. My name is Raquel Rodriguez, the events manager here at Security Compass and your host for today's webinar. Before we get started, I'd just like to address a couple of housekeeping items. Firstly, a recording of this webinar will be available after today's events. You will receive an email with a link to the recording, so if you miss anything, you'll have that for you. Second, we encourage everyone to raise questions, so please submit your questions into the Q&A chat and we'll collect and address them at the end of the presentation. We hold webinars that deep dive into a range of cybersecurity, privacy, compliance, and software risk topics monthly. If you have attended any of our past webinars, welcome back. For those of you who may not be aware of us until today, Security Compass was founded in 2004 and started out with a team of experienced penetration testers. Today, we enable organizations to accelerate time to market for software development as they shift to DevSecOps. With SD Elements, our flagship product, organizations can deliver software quickly and reduce costs through automation. Our modular role-based e-learning solutions empower organizations to embrace DevSecOps, and our strategic advisory services offer expertise in cloud security, pen testing, and red teaming. For today's webinar, we're going to take a closer look at common security challenges within Docker containers and how you can protect these during runtime. I'm pleased to have here with me Avinash Thapa, who is a security consultant here at Security Compass. Please note that throughout the webinar, there will be a couple polls that will pop up. If you are able to, please respond to these questions within the time frame attached. Thank you so much. And without further ado, Avinash, thank you so much for being here with me today. I'll let you introduce yourself and you can take it from here.
Thanks, Raquel. Hey guys, thanks for joining this webinar. My name is Avinash and I'm part of advisory team of Security Compass. So I think we have one poll which is starting now. Please spare some time to complete this one. Then we'll start with the presentation. Okay. So here is the agenda for today's webinar. We will be discussing about containerization and some of their properties. Then we'll talk about how the world of virtualization actually has been evolved to the containerization and what sort of benefits or advantages it adds to the organization nowadays. Going forward, we will discuss the perspective of IT professionals and trends within the organization for the container adoption. And then we'll talk about the topmost reasons to understand why people are loving containers instead of traditional virtual machines. You'll get the overview of the organization challenges that they are facing in terms of security. Further, we will investigate the popular attack vectors that have been used to breach container-based environments with some video demonstration. And at last, we will discuss the high-level checklist from the security context to overcome these challenges. So I would like to start with the quick refreshers on containerization and their properties. So first of all, containerization is actually a lightweight alternative to full machine virtualization, which encapsulates an application in a bundle running within its own operating system. Containers can be installed anywhere depending on your choice. For an example, if you want to install containers on bare metal servers, you can do that. It can be installed on virtual machines and does have options to deploy on cloud. Deploying containers on these platforms have their own advantages and disadvantages. Now we have something called as containerization engine, which is actually a runtime engine that we usually install on the host operating system. And it becomes a channel to share the operating system with the other containers on the same host. We can install containerization engine on both Windows and Linux-based operating system. The most popular containerization engine currently in market is Docker, and also we can run any application of our choice as a container, and some of the examples are present in the diagram. Container operates independently of others, which actually helps them to prevent several interdependencies and safeguard them from the single point of failure. it's good to note that also it's easy to deploy containers from dev environment to the operational environment, or more precisely production environment. And surprisingly, it solves several inter-team conflicts as well in terms of dependencies, in terms of changing of the environment of application that they're planning to deploy. Virtualization and the containerization are the two approaches when it comes to enable scalability, standardizing the software development, deployment, and management across the multiple platforms. As you can see in the diagram, there's a huge evolution happened from the world of virtualization to the containerization. From the diagram, it is easy to understand that virtual machine is actually a copy of a complete server, basically has its own operating system, which means replication of binaries, replication of drivers or libraries between the different VMs running on the same server, and actually a wastage of significant server resources. On the other hand, in containerization, there is only one host operating system which is shared by all the containers. Though container shares the host operating system, containerization provides an isolation to run your applications while sharing the same OS resources. Well, virtualization also provides similar flavor of isolation, but it has its own operating system, which means extra consumption of resources, memories, CPU, etc., and ultimately increases the headache of maintaining a guest operating system in parallel to the applications and their libraries. So in conclusion, we can say that if we have 4 node APIs running on the different version of nodes, it may be possible if we deploy them in a VM, they may break because of the different version of nodes. But if we deploy them as a container, they will be completely isolated from each other and will work seamlessly. So with all the advantages that container provides, it would be best to call containers beyond virtualization. Docker containers are very fast. They can be deployed into production very quickly with the new features and can also be rolled back to the previous one if there is any requirement. Containerized application, or I would say Docker containers, are very portable as well, as it is easy to move them from one environment to the another. Essentially, we can just take a snapshot of the environment, upload into the registry, and download the image from there. In short, the applications can be shuttled easily between the environments. Any host with the Docker runtime installed can become a developer laptops and run containers seamlessly. Also, it untangles several conflicts between the teams. It unites developers and system administrator. Last but not the least, container generates very less overhead on the host and on the application, which improves the performance significantly. The advent of the continuous integration and continuous delivery actually revamped the traditional application development process in a drastic way. The CI/CD based processes, which involve DevOps, brings developers, QA engineers, or operation managers together on a one platform and generates frequent feedback at every stage and follows an automated process across your build, test, or the production environment. So bringing containerization on CI/CD pipeline have several advantages over the traditional software development process. First is optimum use of infrastructure and faster application deployment. So as we have already discussed that containers are lightweight, they are portable. So just because of that. Then second one is your one-click infrastructure provisioning and decommissioning. So it's like quick and dirty way to dev and test your environments for the CI/CD pipelines. After that, faster and error-proof deployment, so which removes all sort of technical snags which are related to the library conflicts, driver compatibility, etc. And at last, automation. The CI/CD framework over the containers can automatically build, package, and deploy the applications. To achieve the automations in a workflow, the most popular orchestration platform uses Kubernetes. So when I say orchestration, I mean orchestration in DevOps, which is like automated configuration, management, or coordination of a different computer system and services. So in orchestration, usually what happens, you can automate the entire process, or you can also automate the entire workflow, which involves many steps across the multiple different systems. Orchestration actually helps you to streamline and optimize frequently occurring processes and workflows, which can support your DevOps approach and helps your team to deploy applications more quickly. Anyways, The Kubernetes, which we were talking about, is actually open source platform that automates the container operation. It eliminates many of the manual processes involved in deploying and scaling containerized applications. The Kubernetes segment actually has a substantial growth from 2018 to 2020. There was a survey which was conducted by StackRox in which 86% of the respondents of the survey were using Kubernetes as a way to orchestrate their container operations in the workflow, which shows that Kubernetes continues to dominate the container orchestration market. So, well, there are lots of things that you can handle with the Kubernetes, such as you can orchestrate multiple containers across the multiple platforms, health check capabilities, self-healing of the application capabilities, and things like that. With the rising awareness among the consumers and their expectation towards acquiring the digital experience, actually has imposed a huge pressure on the core applications to be more flexible. This in turn triggered the organizations to embrace rapid innovation, which is why organizations are prioritizing their digital transformation. The containerization of the application has been increasingly adopted in the recent time. The organizations are leveraging containers to modernize their legacy applications, streamlining their infrastructures, and to be able to market their innovation faster. Data from the surveys shows that there is a great in the surge of containerized of the application. The percentage of the organization that have containerized more than half of their application is actually increased from 23% to 29% in 2020. The analyst firm Gartner predicted that by 2023, 70% of the organization will be running 3 or more than 3 containerized application in the production, which means increasing the market revenue going forward. Also, recently, Docker as an organization have reported that over 5.8 millions of applications have been deployed in containers using their technology, and over 105 billion applications have downloaded so far, and many more projects are going on with the Docker. So such statistics prompts the increase in the use of containers for the application management. Well, container adoption is all about driving your developers' efficiency, and here are the topmost reasons that why people are loving containers instead of traditional virtualization. Increasing developers' efficiency and the speed is the primary driver for the container adoption, with the 37% of the respondents listing it as a top benefit. 20% of them are listed as increase in agility. 19% of them listed as actually it has ability to run on multiple platforms. Also, the organizations who adopted containers are saving costs for the deployment of the infrastructure. This indicates that containerization plays actually key role in organization DevOps strategy in the digital transformation. So if you do decide to move in the direction of containerization, keep in mind that the traditional security model is no longer valid, and we may have to redesign on how we approach to compliance and security. For an example, many of the current security tools are host-based, and when you are removing the dependency of host, you are probably now in the market looking for new tools and strategies. So here we have another poll, and the idea for this poll to get the perspective on what you guys feel is the biggest challenge on adopting containerization in the organization. Okay, so I think if you have completed the poll, we can resume the presentation now. So actually, security is frequently mentioned as the top concern for the moving to the containers. Enterprises are not confident that their base images that they're deploying as the containers are secure before trusting sensitive data in the containers application. And they're trying to find new ways on how they overcome these kind of challenges. So surveys were conducted asking broad range of questions to the IT professionals, specifically emphasis on the security. So some of the key findings from the security perspective is that 44% of the organizations have delayed deploying the application into the production due to the security concerns. Now let's do one thing. Let's see the results of our second poll. and see what are attendance things, what are the main challenges. So as you can see here, it looks like security is actually a biggest challenge, right? And and there are other challenges as well, like deployment and infrastructure, because these things like deploying an infrastructure requires significant expertise, and if we are lacking on those things, then it ultimately causes security issues. So there's no doubt that cybersecurity organizations must have to deal with the growing and increasingly complex attack surface. But what about their defenses? Where do they feel most confident or least confident? The big picture on the right-hand side has been consistent for the years. When asked IT professionals to rate their organization's ability to defend against cyber threats, respondents have been more confident about the assets which are under their direct control and the assets which are easier to monitor, patch, and remediate. So these includes physical servers, virtual servers, databases, applications, etc. Not surprisingly, IT professionals are more concerned about the containers. Like I said before, the traditional security model is no longer valid if I'm considering myself to the digital transformation and have to redesign on how we're going to approach to security and compliance. Whether you are using containers to build your application from the ground up or porting your existing monolithic application to the containerized environments, you need to realize that container environments introduce unique set of security challenges that you should be ready to address from day one. Here are the topmost attack surfaces by which organization faces security risks during the deployment or after the deployment of the containerized applications. Firstly, it's related to the operating system and kernel level attacks. So these are related to the host operating system on which your containerized engine is hosted. If my operating system is not secure with the proper access controls or with the proper patches, you may face consequences in terms of security. DDoS are the most common examples for OS level attacks. As you can see, um, containers can share the kernel resources. So if any of the container is able to monopolize its access to certain resources, it can expel the other containers on the host. In kernel level attacks, unlike virtual machines, kernel is shared among all the containers. And if any attacker is able to compromise a host system with some sort of kernel level exploit, then container isolation and safeguard would help you there. Other type of attack surfaces involves network-based attack, which are pretty straightforward. By default, every container in the network can talk to each other and there's no segregation between them. So if that's the case and we have kept the default settings, then there might be possibility that things may turn to custard if any of the attacks happens on the container. Then we have another daemon-based attacks, which are related, which are further categorized into Docker misconfigurations, container breakouts. So creating a container with the privilege flags are one type of misconfiguration, and adding a user on the host and again adding that particular user in a Docker group is another sort of misconfiguration. So if any potential privilege escalation attack occurs where user gains the elevated privilege through bug in the application code, breakouts are possible. And at last, the most common attack surface is via insecure images, or you may say poisoned images. Maybe you are downloading the images from the untrusted resources, or maybe you're downloading from the trusted resources and trying to build up the containers using the image without confirming the vulnerabilities associated with them. Then both the data on the container and on the host are at risk. So we have a couple of demonstration associated with the attack surfaces that we have discussed in previous slide. But before getting into them directly, I would like to touch base on the basics of Docker files, images, and containers. So Docker file is a text document, or you may say it's some sort of template, which contains all the commands a user could call on the command line to assemble the image. Then Docker image is something which is built from the Docker file, and it's an executable version of the application which relies on the host operating system. The Docker images can be downloaded from the registry such as Docker Hub, or maybe registry which is maintained privately within the organization. So Docker images mainly consist of base operating system with the components of the application that you want to deploy in association with the libraries or any packages which are required by the application. So it's something like ready to go package. And at last, the Docker containers is something which is a running state of a image, Docker image. So let us get started with our first demonstration, which is related to the insecure images. Here you can see an image of a Docker file, which we have discussed earlier. And this Docker file contains some commands. First command says, download this base operating system image from this particular repository. So first thing to notice here that you never know whether this repository is an official source to download the image or not until unless you manually go and check it. Second command says who is a maintainer of this repository. It can be anything. And third command says run these commands while building the images and install these packages on the base operating system. And then after it asks to expose a port number 80 and 443 when the images will run as a container and run these further commands. So facts to notice here. First, I'm not downloading this image from the trusted resource, and image might not be scanned for the vulnerabilities, or maybe from the repository where I'm downloading this image from is compromised and malicious image is provided instead of the real one. Thirdly, what about the packages which are pre-installed on the image, whether those packages are updated or not? So if we run this image without verifying, there will be lots of vulnerabilities which we need to fix going forward. So to discuss the security concerns associated with the insecure images, let us consider a model of a DevOps pipeline shown in the diagram. This model pipeline is configured to automatically build, test, and publish image repositories when one of the event occurs. Either a software engineer commits their changes to the version control system, then this pipeline should be triggered, or operational engineer who is also part of a development team instruct the container orchestrator to perform deployment based on the latest image from the private repository to the operational environment. If any of the event occurs, this pipeline will start. So using such a pipeline, there are several attack vectors could be possible, but we will be only discussing the attack scenarios which are associated to insecure images. So let us assume the upstream source from which is actually responsible for the base image is compromised and malicious base image is provided, or images downloaded from the upstream source is full of vulnerabilities and packages are not updated. Then the build automation will automatically fetch and build a new image based on the vulnerable image and store it in the private repository without verifying the vulnerabilities associated with the image. So in this way, the vulnerable images traveled from the public repository and resided inside the organization under some private repository. Unless detected, a newly built image may then be deployed to the operational environment. So now as a security engineers, we can introduce an additional step here on the step number 3, which will scan the images after it downloads from the public repository, or maybe you can introduce the scanning step after the build is complete. But it would be recommended to scan the images at the first place and avoid the possibility to add the vulnerable image to the private repository. So we can utilize several open source tools, and here's the demonstration which is associated with it. So this video demonstration actually exposes the vulnerability in the Docker images before running them as a container. So I am using open source tool such as Anchor to scan the potential vulnerable images. So the scanner will check how many images are present and whether those analyzed or not already. So at the end of the video, you'll see lots of vulnerabilities were exposed and which are tagged with the high severities. And to make your life easy to explore about the vulnerabilities, CVIDs are also mentioned there. So now let's imagine while incorporating the images from the third-party resources into the supply chain or into the pipeline, the security engineers are ensuring that the images that they're receiving from the trusted resources only and their integrity has been verified. So can we imagine now our entire pipeline secure? No, obviously not. Because as you can see in the pipeline, the container orchestrator, which could be anything, which could be your Kubernetes, which could be your OpenShift, or which could be your Docker Swarm, has a complete control over the operational environment. Okay. And and it makes an attractive target to the attackers as well. So for an instance, the operational engineer who is a part of the development team instruct the containers to run the orchestrator to perform any deployment based on the operation environment with the images from the private repository. Now here the container orchestration platforms are misconfigured and they are deploying the containers with the privilege flag enabled. The application will get deployed on the operation environment and will be available on the internet to the external user. So if the application is available on the internet, which means it's a potential target for the attackers as well. And if an attacker can't find the vulnerability of remote code execution on the application, attacker might be able to get the access on the containers from where the application is displayed. If my pipeline is completely secure and every containers have stringent access control, then attacker won't be able to do anything else and his activities will be limited to the containers only. So as a part of fix, you just need to deploy another container with a fix of the vulnerability, but that's not the case as of now. Because if you recall that our containers were deployed with the privilege flag enable as part of an example, and exploiting them will provide access to the operating system where containers are deployed. So we have a video demonstration to illustrate this example. The demo was created with the assumption that attackers were able to get access on the containers, which was deployed with the privilege flag, and now how he can break out the containers to achieve access on the host operating system. So here is our second demonstration, which leverages the misconfiguration of the privilege flags. So there's a file created under the temp directory on the host operating system with the name secret.txt, then spun up the containers with the privilege flag enable. So as attacker, he have access to Docker instance now, a Docker container now. So he will play with different binaries and finds out that host operating system is mounted with the container. Then attacker may go ahead and try to mount those file systems and eventually will be able to gain the access on the host operating system and also can read our secret text file. So like these, there are several other attack scenarios can be possible, which some of them are complex to exploit or some of them are very easy to exploit. So what should be our best practices here? So I have divided the entire journey of the containerization into 3 phases: the build phase, the ship phase, and run phase. So these are the high level checklists that we can consider before or means while doing any deployment. So image scanning should be the first thing before any sort of deployment. So this should be part of the process that whenever you're downloading an image, so it should undergo scanning to expose any vulnerabilities. You can do the code analysis of the application that you want to deploy. In shipping phase, you can perform the image signing with some sort of cryptographic verification model and uses access control to access the repository where images are resided. Under the pre-deployment phase, you can ensure that your host security checks are complete, all the patches are regularly updated, secret management, things like that. And when containers are actually deployed, container activities must be monitored and team need to be able to detect and respond to any security incident. So it is suggested that to monitor for the suspicious network calls, API calls, or any unusual login attempt. So team should be having predefined mitigation steps for the containers and should be able to isolate the containers on the different network until the threat is identified. At last, there is one very informative guidelines from the NIST, which is worth looking if you are planning to create a pipeline or maybe planning to increase the security controls in a pipeline from both technical as well as from the process perspective. So with that said, actually, I would like to conclude my presentation here. So these are the topics that we have discussed in this webinar. And we have a next webinar on 21st of May, which is an extension of this particular webinar, which will be complete deep dive on to other possible attack vectors, which could potentially the security risk for the organization and detailed best practices and mitigations from the security perspective. Thanks, everyone. Now, if you have some questions regarding the webinar, you may please ask us.
Yes, thank you so much, Avinash, for doing a deep dive on container security. Like he had mentioned, at this point, we would like to open it up to questions. So if you have not submitted your questions through the chat yet, please do so now. We do have some questions that come in, Avinash, so I will get started with the first one. The question is patch management still important when working with containers? And if yes, what are some recommendations to implement it?
Yeah, so yes, actually, patch management is recommended and it's required, it's important step if you are working with the containers. So when we are talking about the patch management, it has actually three aspects. First aspect is patching on the running containers. Second would be patches on the container images. And third would be patches on the host operating system where my containers are running. So let's talk about the first aspect actually. So which is like patching on containers which are running. Well, this cannot be possible. We cannot patch any containers which are already running in the environment because patching a containers has a complete different concept from the patching of VM. So containers are actually meant to be immutable. So it means nothing can be changed in the containers if they are deployed. And if there is any vulnerability which require patches, so you may have to rebuild and redeploy the whole image, which is why we say that containers lives very shortly and things like that. Second aspect is like patching of the container images. Yes, that can be possible. So you can patch the images which are residing in the image repository. So by doing so, a fully patched container image can be rolled out and rolled back as a one unit. So that the patch rollout process will be the same as your code patch out process. And the last aspect, which is like patching a host machine, as the host machine is actually a larger attack surface from the attacker perspective. So we should be thinking how we can minimize those attack surfaces. So instead of using general purpose operating system to deploy the containers, instead we can use container based host operating system, which can be used to deploy containers. And the container based host operating system are specifically designed to host containers only and have very stringent access controls, and several functionalities are disabled. So if for some reason, if you're thinking that you have to use general purpose operating system, then host should be continuously scanned for the vulnerabilities and updates, not only on the container, but also on the lower levels for the components such as kernel. So I believe if this answers this your question, so.
Perfect. Our next question is, do I need to do security review or testing on each container I have, or just in the container orchestration platform?
Okay, so well, both of the components should be taken into consideration if I'm performing any security review. So the reason is like both orchestration platform and the containers have the different set of security issues, or maybe more precisely different attack surfaces. So for an example, the orchestrator risk should be something like unbounded administrative access, maybe issues related to the joining of the untrusted node in the cluster. So these are the issues which are related to the orchestrator platforms. And when we are talking about the containers, so the risk should be something like, this could be something like vulnerabilities which are deployed in the containers. What about the things? What are the testing of those things? Then attacks which are related to the container breakouts, or probably unbounded network access from the container. So these two aspects have different attack surfaces. So they should be um, taken into consideration while doing any security review. Yeah.
Great. Next question is, what approaches can you take to do a container penetration test?
So an entire approach or the methodology can be actually divided into three parts. First thing, we should be checking for the techniques to identify whether we are inside the container or you're on the host. So for an example, I am testing a website, but that website is actually hosted on a container. And I was able to get a remote code execution on that application, and I have access to the container now. But I don't know whether it's actually a container or it's actually a host operating system. So first step should be to check whether you have access to the container or you have access to the host. Secondly, it corresponds to the container escaping technique. So we usually take the perspective of the process inside a container and know how we can see that how we can perform container escape attacks. Third, it would be attacks on the attacker daemon. We'll take the perspective of unprivileged process on the host with the Docker install and how we could perform Docker daemon based attacks. Yeah.
Perfect. And we just have one more question that we'll have time to answer. Can I automate security review of containers?
Yes, you can automate the security reviews of containers, but not all the components. Some of the components you can automate. So if I'm talking about some of the components, so that components related to the host configuration scanning things, that things you can automate, such as you can use Docker Bench for security for the host on which your containerization engine is running. So there are several tools are available which can analyze your containers at runtime, such as DocScan. Even there are some exploiters that are also available that you can utilize, such as BOTB, which is like break out of the box, which actually exploits the trivial container bypass techniques in the running containers. Yeah.
Perfect. So thank you so much, Avinash. Again, it was a great session. If you had a question that we weren't able to answer, a lot of these questions will actually be answered in part 2, which will be taking place on May 21st. So please feel free to register for that webinar. Again, we will provide a link to the recording of this webinar to everyone here via email. So if you miss anything, no worries about that. So thank you so much again to everyone for attending this webinar. Please stay well and safe and have a great day.